Okay, so I am going to hopefully present. Okay, can everybody see the first slide?
Looks good.
Okay, awesome. So thank you. As Andy said, my name is Charlotte Sheeran. I'm with the Critical Area Commission, and today I'm going to be presenting on stormwater management in the critical area. So the natural resources law that governs the critical area requires a 10% reduction in pollutants post-development within the intensely developed area for local and private development projects. This is meant to address water quality improvements in the IDA. In the limited development area and the resource conservation area, or the LDA and RCA, water quality is addressed through the lot coverage limitations, which hopefully everybody's pretty familiar with, and I think we've covered in previous presentations. So the 10% pollutant reduction requirement is separate from the Maryland Department of Environment's environmental site design requirements. MDE's requirements are triggered by 5,000 square feet of disturbance anywhere, whereas the critical areas requirements are triggered by 250 square feet of disturbance within the IDA for local and private development projects. Critical area stormwater is required in all critical area designations for state projects. The 10% rule is quantified as a 10% reduction in phosphorus because phosphorus is considered a limiting nutrient and is an indicator of other pollutants such as sediment. So how does this spreadsheet work? So I'm going to hopefully open up our website. Can everybody see that?
Yes.
Okay, fantastic. So this is the Critical Areas website, specifically under our Stormwater heading, which you can click on over here on the left-hand side. So on this page, you will find our Stormwater manual and our 10% spreadsheet, as well as MDE's requirements. So this is just a quick resource location for all things stormwater, basically in the critical area. So if you click on the 10% spreadsheet, you'll see it has downloaded it, and we can open it up, hopefully. Okay, so are you now seeing the spreadsheet?
Yep, looks good.
Okay, awesome. So I'm going to go over an example of how to use the spreadsheet for an actual project later in the presentation, but this is just a quick overview of what the spreadsheet is, what it looks like, and generally how to use it. So critical area staff worked with, I believe, MDE staff and the Chesapeake Stormwater Network staff to create this spreadsheet. And basically, it was created to just provide an easier way to calculate the 10% reduction requirement. So generally, the blue cells, the cells highlighted in this bright blue color, are where you're going to actually input information. If a cell is grayed out, that means it has a calculation or equation associated with it, so you do not want to edit those cells. So the spreadsheet basically enables you to input information about your site. So in this case, you're inputting the site area. So that's the total area of the site. We can just do generally 1 acre. Your existing impervious should also be inputted in acres. And then your proposed impervious is actually, after development, the total impervious that will be on site. So that includes what was there before, the existing, plus anything that's added and then also minus anything that may be removed as part of the redevelopment. So you'll also need to input the soil type. And this information can be found on the Web Soil Survey, which is another online resource. And I don't have an example of going through that, but I am happy to assist anyone. I can provide the website. It's relatively easy to walk through determining your soil type, but we can go into that more detail if needed later. So you would basically put in the percentage of various soil types on the site. So you could have 25, 25, 25 even. You would input that there. And then you'll see over here that it gives you what your reduction requirement is, 0.67. So then along the bottom here, there are various separate sheets for each individual best management practice that is listed under MDE's environmental site design regulations. So you would click through here. There's several of them. We're going to go into a little bit more detail on a couple of these later in the presentation, but basically you're inputting information about each practice. Again, you're only using the blue cells. And that will then carry over to both this first page. Down here, it'll kind of tally or total the different practices you've entered on this page, and then you can use your calculation summary to determine whether you've met your requirement. So here, obviously, I haven't inputted any best management practices in, so it's still it's telling me I still have this 0.67 reduction requirement. Okay, so going back to presentation. So like I said, I'm going to cover a couple of the more common practices that you all might see when you're reviewing stormwater plans. So rooftop disconnection involves directing flow from a rooftop downspout onto a vegetated area where the water can then soak into or filter over the ground. This disconnects the rooftop from the sewer or storm drain system and reduces both runoff and pollutants delivered to receiving waters. Maintenance of areas receiving disconnection runoff is generally no different than what would be required for lawn or landscaped areas. And the areas receiving runoff should be protected from future compaction or development of impervious area. So if you're looking at a plan that is directing runoff to an area that later is proposed for like a patio or a pool or some other structure, that disconnect is no longer functioning as it was designed. So that's something to keep in mind when you're looking at these plans. Non-rooftop disconnect is basically when you direct flow from impervious surfaces such as driveways, streets, or sidewalks onto vegetated areas where it can then soak into or filter over the ground. So you'll see down here in this schematic, you have a driveway and the flow is being directed sort of across this area here with a transition strip right along the driveway and then an open expanse of where the flow path will go. So I'm not going to go over these in great detail, but this basically provides a quick summary of the requirements found in MDE's stormwater manual when it comes to these two practices. So there are actually many design specifications that should be considered if you're reviewing a plan that includes, rooftop disconnect or non-rooftop disconnect. There's a lot of requirements associated with them. So, in order to accurately and appropriately review your plan, you should be verifying all of this information when you're looking at the plans. So another practice that I'm guessing you all probably see a bit in the municipalities are rain gardens. So a rain garden is basically an excavated landscape feature that temporarily holds runoff for a short period of time. Rain gardens typically consist of an absorbent planted soil bed, a mulch layer, a gravel filter chamber, and planting materials such as shrubs, grasses, and flowers. An overflow conveyance system is usually included so that larger storms completely bypass the rain garden so that they do not, destroy it basically with the larger flows. Captured runoff from downspouts, roof drains, pipes, swales, or curb openings are often directed toward rain gardens, where the water temporarily ponds and then slowly filters into the soil over 24 to 72 hours. And again, these are some of the design criteria associated with rain gardens, and can also be found in MDE's Stormwater Manual. Specifically Chapter 5, that's where all of the ESD best management practices are listed, and all of these design criteria are laid out. This is just a kind of example schematic that our office actually worked with an intern to put together. It kind of lays out just like a general specification and design criteria for installing a rain garden. So as an alternative to using these on-site best management practices, some jurisdictions do collect a fee in lieu for stormwater management. And the current rate for fee in lieu for stormwater management, as set by MDE, is $35,000 per pound of phosphorus removed. So if a jurisdiction wishes to collect fee in lieu for stormwater, it should really set up a program to manage, track, and implement that fee in lieu, so that the fee in lieu account is kind of kept separate from other accounts that you may be collecting fee in lieu for, so that you can ensure that money is put towards water quality improvements within the critical area. Our stormwater management manual, the critical area one, which is located on our website, also has guidance for fee in lieu and offsets. So planting to meet the 10% requirement. So this is another option that we very typically see in small jurisdictions, mostly because of the types of projects that you're reviewing that might require 10%. So it's very often these small residential projects, maybe they're putting an addition on their home or an accessory structure, and they have a 10% requirement. So planting trees and shrubs to meet that requirement is often an option. Typically, the conversion we use is 100 square feet of disturbance equals a requirement to plant 1 3/4 inch caliper tree for these small residential projects. We also have a conversion that we've used for larger requirements, which is basically that 2 pounds of phosphorus equals 1 acre of plantings, where 1 acre is equivalent to about 400 woody stems. So you can use that conversion to kind of backtrack if you have, something that's not a small residential project where they want to meet some or, a part of their stormwater requirement using plantings. So critical area in the buffer. In general, we do not allow stormwater management to be placed in the buffer. The exception to this would be in the MBA, or the modified buffer area, which likely being from municipalities, you all probably have a fair amount of MBA in your jurisdiction. So because of the nature of the MBA, the fact that there's likely already development within the buffer. It's often on smaller waterfront lots where there isn't a lot of room outside the buffer. We do often see stormwater management placed in the buffer simply because of the nature of the lot and what it looks like. So stormwater pipes and outfalls are allowed within the buffer. Obviously, it's going to be necessary, particularly when you're discharging to tidal waters. You're going to have to go through the buffer at some point. So, however, the buffer is not supposed to be used for disconnection purposes. So earlier we talked about rooftop and non-rooftop disconnects, which have, a flow path associated with them that the rooftop runoff or non-rooftop runoff is supposed to kind of flow through, and there's a specific length associated with that flow path. So the buffer is not supposed to be counted as part of that flow path. So if say your house is constructed 50 feet from the 100-foot buffer line, the max flow path you might be able to achieve using a rooftop disconnect there would be 50 feet, because once it hits the buffer, you're not supposed to be counting the flow path after that. And the same is also true for the best management practice known as sheet flow to conservation area. There is an exception to this if the minimum distance can't be achieved, again, because of the location, because of the layout of the property. You may be in the buffer regardless. And so there are some exceptions to that standard. And then finally, regenerative stormwater conveyances, also known as coastal plain outfalls, are permitted within the buffer in order to correct erosion around stormwater outfalls or within a stream valley. Okay, so I am going to run through a quick example of a site plan that might be typical of what you would receive in a municipality and how to calculate your 10% reduction from that. So if you want, you can actually download the 10% spreadsheet from the website and kind of like follow along as we fill in the information. I'm going to use like screenshots from the spreadsheet that I filled in previously when I was creating my PowerPoint. So but feel free to kind of follow along. So in this case, this was an example from the town of Betterton, where it was a residential lot. They were putting in, I believe, a driveway and walkway, but there was a dwelling located on the property already. So they had a certain amount of existing impervious that was going to remain. And then they were adding this sidewalk and driveway area. So this was the site plan that we received from the town of Betterton. So again, I wanted to pick an example that was maybe typical of what you all are going to see within the municipality. So, this is not a professionally engineered plan. It's obviously an applicant probably put it together themselves. So, I just want to show that you can still get the information you need from the applicants, even if you're, working directly with an applicant to create their submittal, and there aren't like a bunch of professional engineers involved. So the checklist on the spreadsheet is kind of the first step. This basically just kind of lays out the things that we should be looking at and researching prior to calculating the stormwater requirement. And this is, just for your own edification purposes to kind of have a summary of like what the site looks like and what's there. So as I said before, we know that the site area was 0.24 acres. The existing impervious was 0.04 acres, and the proposed was 0.01. So the total that goes in this this cell is 0.05. So that's the 0.04 of existing plus the 0.01 of the proposed. And then again, we used the web soil survey to determine that the soil type was 100% B soils on the site. So this gave us a pollutant reduction requirement then of 0.04 pounds per year of phosphorus to be removed. So the applicant decided that they were going to meet this requirement using permeable pavers. This is all that was given to the town and to our staff when we were reviewing this with them. Just this very small spec of what a permeable paver looks like. I took this as a screenshot from a PDF, but trust me, it was not really any more clear in the materials submitted. So using this information that we were able to discern from this spec for a permeable paver, we then were able to enter that into the correct tab on the 10% spreadsheet. So with permeable pavers, you'll notice there's several different tabs associated with permeable pavers. And the letter A, B, or C corresponds to the soil type. So you want to make sure, in this case, we knew it was B soils. So we're entering it in the tab for permeable pavers B. So the total proposed impervious on this site was 630 acres for the sidewalk and driveway. And so that is your contributing drainage area for permeable pavers. It's basically the area of the permeable pavers themselves, because the rain is, falling directly on those pavers, and then the pavers are doing their job to absorb the rain, filter excess nutrients out, the phosphorus and the nitrogen, and then filtering into the groundwater. So, and then based on the spec that they provided, the thickness of the permeable pavers themselves was 12 inches. So let's see. Yes, so then going back to the summary tab, once we entered that information into the permeable paver tab, we went back to the calculation summary tab on the spreadsheet. And you can see here that their requirement was 0.04 pounds of phosphorus per year. The permeable paver information got them a deduction of 0.03 pounds. So they actually have a remaining requirement of 0.01. And the applicant in this case met that additional requirement, the additional reduction remaining, by planting 2 native trees on their property. So that is just kind of a brief overview of our stormwater management requirement, what it is, what the spreadsheet is, how to use the spreadsheet. So I will take any questions at this time.
Should I just go ahead?
Yes, Bruna, sorry, it looks like your hand's up. Sorry, I was trying to get back to the screen.
Thank you. So I saw that you had a slide earlier that talked about the credits for plantings. But how does that translate? How do we calculate that, and how does that translate? So the last slide that you had was a 0.01 pounds of phosphorus remaining. Mm-hmm. Then you mentioned 2 native trees. So is there like a rule of thumb?
So that's where I think what we used there, if I remember the calculations correctly, we used the, so it's 0.01 pounds of phosphorus. And so we had to convert that using the 1 acre of trees equals 2 pounds. So we kind of had to like back calculate it to get the 2 trees for the 0.01. So if you think about 2 pounds of phosphorus equaling 1 acre of trees, and then 1 acre of trees equals 400 stems, we kind of back calculated it to figure out how much 0.01 pounds equaled in acres, and then how many trees that equaled. Does that make sense?
Yes. Yes.
Okay.
I think it does. Yeah. Thank you.
Sure.
Well, then, if I may jump in again.
Sure.
So are there any plans to update the 10% spreadsheet, because it's been in draft format for a while, and it would be helpful to have a tab that includes that calculation for vegetation to meet the load removal requirement?
So I don't know that we have plans to update the 10% spreadsheet anytime soon. We have been having conversations about stormwater in general, and moving forward, how that should be handled in the critical area. But I think for now, we are using that spreadsheet. It does, it's not perfect, and it does have some weird little like idiosyncrasies, I think is the best way to put it. But if you ever run into problems using it, feel free to reach out to staff, and we can hopefully figure out the issue and how to resolve it. Are there any other questions? Okay, I'm gonna turn it over to Cheryl.
Okay, do we have something?
Yes. And I just was able to get my PDF open as well. So
okay, we'll try to do it this way. It's certainly not the best, and I surely apologize, but
that's okay.
I'm not having much luck. So, town of Oxford. As you can see, we're completely surrounded by water. We are almost 100% within the critical area, 1,000 square feet. And we have a very large BMA. In 2016, we worked with Critical Area Commission to do a case study for coastal resilience. And one of the things that we brought to their attention at the time was we really needed a better way to request mitigation that met our needs. And it was a really good project, and it resulted in us changing our regulations to something that was more beneficial for our town while taking care of what critical area wants us to take care of. One of the main components was actually adding language within our regulations for bioswales and rain gardens as mitigation, along with rain barrels, because trees are very nice, but trees don't really do what we needed to do and are just not always the 100% solution. One of the things we use quite often is this photo here. It's actually a drawing from Montgomery County and critical area staff, which really gives the average resident a way to look at things, the things that can be done that are different than what they expect. And rain barrels are a great solution for quick, easy mitigation, and we do use them quite often on very tight lots where somebody's trying to add a small component to their house and need to mitigate and don't really have room for planting. But the one thing we really do is we try to allow for flexibility and creativeness in design so that we are reaching a better standard and doing a better job by looking outside the box and doing things that work for us. Because as a completely built out IDA with a lot of historic property, it can be very difficult to meet the criteria. Let's skip ahead here. This was, let's say in the right top corner, was a commercial structure that was 100% impervious. asphalt or building from the 1880s. The asphalt, of course, is newer, but the ground was completely covered. In the renovation of the building, which you can still see in the bottom left here in the back, and then in the footprint of the addition, which was actually allowing them to do a 2-story where they originally had a 1-story, opened up some opportunities to add stormwater management and improve their coverage. So in Oxford, we have a 40% coverage limit on residential and a 50% coverage limit on commercial. But the issue is when you have a property at 100% coverage. So working with the construction workers, the landscape architects, and the owner, you try to develop something better. In this case, they did multiple things that really improved this property, which includes a pervious walking path to enter the building as opposed to your typical sidewalk. The introduction of planting beds instead of just grass, and also a major stormwater pond, which is what you see in the middle. So the disconnects from the new and the old structure come into this rather large stormwater rain garden, and they have time to settle down before they actually exit. In addition, they put half of the driveway in pervious pavers and then finished it off in asphalt to enter the street. But all of these improvements were really working with someone to get a better solution for both them and for us, not necessarily because the criteria required them to. This is a hard way to do a presentation. Working with new residential construction, we try to help them also reach a higher standard. And we also try to clarify our expectations with design engineers quite often on a new project. And when I say new project, let me explain. That would be a replacement building on an old lot. So we have very few undeveloped lots. But design engineers are very quick to do the 10% calculation and tell you, you need this many trees and they can go in that corner, and they present their plans. And we try to let them know up front, we expect to see more creative, innovative ideas when they present a new development of a parcel. So this is a sample of a historic buildable lot that is less than 5,000 square feet. And they started with, they were just going to run everything to the swale that runs down the street. And we came back and they were going to add fill to elevate the property. We came back and said, no fill, because you will push the water onto your neighbors. And number two, we want you to manage that stormwater before it gets to the street to extend the amount of time it takes it to reach the streets, because we have stormwater, tidal water flooding all the time. So this project has substantial raised flower beds in order for these disconnects to go through these beds. And these are well-built structures. They're designed as part of a permanent components of the home, which adds longevity to the project, which is a little bit better sometimes than a rain garden, because you've got to keep an eye on rain gardens. And we do require stormwater agreements, so the owner and the next buyer understand there are things they have to follow. But this is an example of working with someone to get something that will be better for them and for us. This is a home that is about 5 or 6 years old. And when she came to us, we kind of clarified that there would be things that would need to be done in order for her to build a house on this lot. This lot actually was a very old lot, and the house sat on the raised bed area here in the front, and all the rainwater from the street ran across the backyard through the mud and into the creek behind it. And in order for her to take down that house and put up a new home, it was going to be necessary to manage that street water. It's a difficult situation because she had her property and she had a right to build on it, but she worked with us. And basically the stormwater does leave the street. She has this grassy area that is all designed to hit this point where that yellow star is at some point, and it goes underneath her sidewalk, again goes into a second grassy area, and eventually runs out into the creek. But that is not her runoff that she's managing with that. That is public runoff. Her runoff is all through disconnects that eventually reach raised beds that, again, like the drawing I just showed you, are part of the infrastructure of the house. She also has a rain garden that sits between her shed and her home that handles rainwater in there. This was a very nice design, a really cooperative owner, and a very good example of how to manage the problems meet the criteria that's necessary for development, and end up with a property that the owner can be proud of. Sadly, I took the pictures in the fall, but they're much prettier in person in the spring. Innovative stormwater design is more attractive for homeowners, but you need to make sure your regulations do not restrict innovation. And we see that quite often. And that's really important to point out, is make sure you allow for creativeness, because every property is a little bit different. And in our case, the smaller properties and municipalities can be very difficult to manage. This is another commercial property that started out as 100% coverage. And as they were redeveloping it, they opened areas up and manage their stormwater too. So one of the things we try to tell people right off is, please figure out how to find more green space and figure out how to slow the stormwater, and that helps us with street flooding. So what you can see here is some very, very large rain barrels. This was rather clever, but these are farm water containment barrels that were incorporated into this project. And all of the disconnects from both of these commercial buildings starts by hitting these rain barrels. They are then turned around and used for plant watering, because this is actually a landscape architect's property. You can see that the walkways are also pervious decks. Again, preventing that laying of sidewalk, cement, and asphalt everywhere is really important to us. And then the backyard, this is a rather creative way to incorporate growing food. So she has peppers that were in really good condition yesterday, and quite surprised to me because it's been kind of cold. But the raised gardens allow her to grow some stuff experimentally outside, and it reduces what was pervious area behind there. Better for all of us. In addition, this is the backside of the same property. Well, this is actually the front here. These are her own version of pervious pavers before we adapted them into our regulations, rather creative. The back of her property, this is the required parking for the commercial space. What she's done, though, is incorporated trees into it to meet her criteria for development. But it really is an innovative way to bring the trees into the project. This is really going to be nice. And once this is fully grown in, great stormwater retention within that coverage. Here's another example of a residential parcel. This gentleman wanted to add a pool. The only place our regulations allowed for it was in this back right corner. But in our opinion from staff, the best place for his stormwater management was in the back right corner. So through a variance process, which we recommended to our Board of Appeals, his pool is in the front yard and his stormwater retention pond is in the backyard. And it's tree planted, which we recommend quite often because we really need as much absorption as we can get. And you can see after 3 years, that's a pretty healthy tree growing back there. Some of the other things we allowed, although it does count as coverage in our regulations, were things like this bed. This is, again, street water that crosses his property to get to the creek, which is back this way. But it runs almost like a babbling brook. The water doesn't rush through it, it trickles through it. And this is one of those things where he wanted to do something that we would not normally have done, but realized in the end this was really a benefit for us and for the homeowner. His neighbor has a similar situation, and again, his runs till it hits grassy swale. Both of these eventually go through grassy swales before they do get to the creek. We also allow them to plant on the street side of their properties, which technically is town property, because that improvement helps us. We incorporated pervious pavers. I'm glad to see they're everywhere now, but we did incorporate them into our own regulations because we realized that there was no reason for someone to put in a pervious paver. There was no benefit to them. And by allowing the coverage reduction, it encourages what we know is better for us. These are examples. The one on the left is my favorite. This is a built to code driveway that you can barely see, and it's a very healthy pervious driveway. The right side is what we generally see in town, which is what we call parking strips, because we have this 40% coverage and very difficult to squeeze your driveways in. Most of them will go for the alternative parking strips where they have brick and grass. But as you can imagine, this certainly breaks up the stormwater by having this element instead of a regular driveway. The other thing we really encourage is pervious brick everywhere. So this sidewalk on the left probably looks to most people like something that needs to be improved or repaired. But in reality, to us, this is a very functional place to walk that is doing a much better job of handling stormwater than a normal sidewalk would. On the right side, we had someone who required some mitigation. She was building a new home on top of the footprint of an old home and was extending the size. So she needed to figure out how to meet her mitigation. This was a driveway, and we told her she would have to remove the driveway. And the requirement, of course, would have been to make it grass. And she came in and requested the raised gardens with the flower beds and stuff. And better for her, better for us, and really an improvement over just having green grass there. Lastly, don't underestimate the role trees play in urban stormwater management. And I don't want you to say we don't discourage trees, but we realize that we can't put a tree everywhere and we need to do different methods. But I will tell you, trees are one of our biggest components of our stormwater management. And this is a watershed protection drawing that really explains to somebody why this works. And I will note the only negative usually is leaf litter. And the way we manage that in Oxford is we pick up leaves regularly, weekly, at least once a week. In the case of this week, because of the winds, we've picked them up 3 times already. But explaining to people that that our tree coverage handles a massive amount of our stormwater long before it hits the streets is really relevant in an area where tidal flooding and stormwater flooding can be such a huge impact. So back in 2016, we adopted what we call a 1-for-1 tree replacement in our critical area regulations. And most of the time it ends up being a 3-for-1 because the average tree in our town are fairly large. But as they need to come down, as they become a threat, we require that they be replaced and substantially replaced. And this is another area where you have to be somewhat creative. You can't always fit 3 trees in an area where there formerly was 1 tree. And rather than set up some type of fee in lieu, we require them to plant a tree. It doesn't necessarily have to be within their lot. It can be on a public lot, in some cases on another lot, but someplace where we need the trees placed and they can mitigate what they're doing on their property. And lastly, as a small town, I always think it's important that you do practice what you preach or what you regulate, and you lead by example so that the public, as they're being required to mitigate, can understand and realize that we're all solving the same issues. For us, it's managing stormwater and tidal water for flooding purposes and mitigating and keeping our bay clean, or cleaning our part of it. So this is a ditch that was originally a ditch. We've opened it up to be a swale, expanded it substantially. And the bottom left is what we now have. The improvement here is visible to the naked eye. We had residents who at first thought we were building a massive swamp come in and say they can't believe how much less stormwater they all see in the roads everywhere, because once it gets into this well-established area, it eventually settles out. We don't even have to wait for the tides to go down most of the time. These are other areas where we did the same thing. These were all open ditches, which used to be the way everything was done. And you'll see all of this sediment and you're thinking, where is that coming from? Way back here inland are ag land. And in a heavy, heavy rain, it just streamed right off of everything into these ditches. So, and these ditches actually reach back to that swale I just showed you on the prior slide. Since that time, with some assistance from the state and some other groups locally here on the shore, we have implemented stormwater management best practices in all of those ditches and swales. The top picture is actually a very large stormwater retention or rain garden where the ag field now drains into that. When it's finished that area and starts to overflow or doesn't get absorbed, it comes down a newly planted swale. These have been in place probably 3 or 4 years now and are really healthy. Let me see if I can get to another one here. I'm getting to the end at least. And then it keeps moving through our system where we have literally planted every ditch or swale. We've improved it to be something other than an open ditch. And sadly, this PDF seems to be ending at this point. So I will stop sharing. Make sure everybody is still there.
That was awesome, Cheryl.
Well, I apologize. Quite disappointed in that we don't even have the ending. But my point was that, you know, we try to work with every single person so that they understand that we all have a goal. But if you don't open yourself up to working towards something and being creative and allowing them to do something that they're happy with, you can't get the same result. So we've learned things the hard way, but it's the best way to do it.
Does anyone have questions for Cheryl?
Hi, Cheryl.
Right.
This is Tay. Thanks, Charlotte. You said that you allow residents to plant on town-owned land because it's beneficial to you guys. Do you have any special mechanism, like who, since it's on your land, are they supposed to maintain it, or are you guys?
So we maintain all of our properties. The only time we ask the residents to maintain is generally street trees that are within there. So most people, their property runs towards the street and there's a few feet and there can be stuff planted there. So if they plant in front of their property, we do anticipate that they will maintain that. But in the public parks and the public beaches, of which Oxford has a substantial amount of public land, once it's planted, we will maintain it. It's a way to keep our coverage in place, our tree coverage, and it helps, you know, to replace the stuff that dies off naturally. And also we've had a lot of open areas, even where there's swales, where we're fairly open areas, and we've been adding trees in this mitigation way since we started. And these areas are becoming treed parks as opposed to open parks.
Okay, I like the idea about, you know, residents being able to plant on town land, even if it's not in a park. That's a great idea.
Yeah, we are pretty open to, you know, we keep an eye on where things are, and sometimes, you know, it's just an improvement. So we have our basic public works facilities and stuff, and pump stations. These are all right next to residential homes and in people's areas. So if they can plant something along the pump station that sits near their house, they feel good about the mitigation too, because it's removing an eyesore for them. So we try to be very creative and put trees where we need trees.
Looks like Jen, you have your hand raised. Jen? Oh,
She
can't unmute. Bruna, I think you have your hand raised.
Yeah, so it's a more general program question. So when we allow a development to meet the 10% rule through tree planting, can those trees, they cannot be counted towards the 15% afforestation requirement, right? Or tree mitigation?
So in development, we separate tree mitigation. So 1-for-1 tree is a separate component. So if somebody's coming in with a project and they need to mitigate their 10%, they have to create those calculations. And then they want to remove 2 trees. Well, then they have to put in 6 trees. And then we go about. Now, in the case of the 6 trees, that's where we have to get more creative, because quite often once they've done their 10% on a very small lot, there is no place to put 6 trees that will eventually be large. And that's where we allow them to put in 2 trees and then put in 4 trees at the nearest public area that would be beneficial. So that's the 1-for-1 tree on top of development. You've got to be creative in order to implement that.
Yeah, well aware. Here in Baltimore City, usually the lots are very already developed, and sometimes that's why one of the reasons why we have a fee in lieu program, because sometimes there's no space to plant within the site. But for like the critical area program in general, the trees, if using like the same question, but like for perhaps to Charlotte, can those trees cannot be counted also towards the 15% afforestation requirement, right?
Kate, correct me if I'm wrong, but I think they would.
Okay.
So we're looking at the lot as a whole meeting 15% afforestation. So I think if the mitigation,
Isn't Baltimore City different?
okay, then I will step away because I'm not familiar.
I think, Bruno, we'd want to look at your program to see specifically, because in general, the 15% afforestation requirement doesn't apply in the RCA or LDA, whereas, 10% in the IDA. But Cheryl has, her program's very special to her. So how she lets things count is very dependent on what we put in their program. And I think we'd want to do the same. We can look at yours as well. So I don't want to say there's a general like yes or no.
Okay. I don't think we have anything in our manual related to that, but perhaps we can talk about that later. It would be
I think
nice to add that. Thank you.
It looks like we're hitting the noon hour. Oh, Jennifer's finally typed her question in. Are you running into any issues with permeable pavers and high water tables? And do you see this soil augmentation is often required? Are you seeing overall success with small properties using the stormwater table for LOD less than 5,000 square feet? And do you think it is overall easier for the homeowner? So yes, the stormwater table, the table we have, I think really makes it easier both for staff and for homeowners. And one of the things is it's hard to send somebody to an engineer to do a project when all they're trying to do is incorporate a small shed or something. So I think Jennifer, the answer to that is yes, I think it has been easier. We haven't had a problem with the permeable pavers and high water tables. In any place, because as you know, most of our lowest lying areas that might be impacted are really just where the streets are. So hopefully that answered that question. The permeable pavers part, though, I think people are really kind of liking the idea, and it's opening up some opportunity to do driveways and walkways better.
Awesome, thank you. Are there other questions that anyone has? Comments?
Yeah, Jennifer commented that she'd like to see some other jurisdictions adopt a stormwater table. And I do think that it's easier for the public to be able to look at our regulations and clearly understand what we expect of them. It's much harder for them to look into critical area regulations and even understand what they're supposed to do, which even with the tree, if it says you have one big tree, you put in 3 trees, making it easier for the public to grasp what's going on is really important.
Yes, that's very true. Comar is not the most user-friendly.
No, more than one place, not just yours.
Okay.
Well, thank you very much. I appreciate the opportunity.
Thank you very much, Cheryl. That was awesome. That was a great presentation. If anyone has other questions or comments, feel free to email us. I think everyone should have a contact here at the commission you can reach out to if there's questions. So thank you all very much for attending.
Thank you, Cheryl.
Thanks.
Thank you very much, Cheryl. Thanks everybody for attending the training today. Hope you enjoy Thanksgiving.
Great, thanks.